Okay, we are working on homework for section 6.2. So the gap illustrates the distribution of the prices of college textbooks. What is the mean of the normal distribution? On the graph, the mean is the spike, which is matching 215. So let's type. Okay, and the standard deviation, how we are going to find out if this is my normal distribution. See these inflection points, and here is our average mean, right, mu, and this is our sigma. So the difference between this difference between the sigma, first sigma and mu, or this one, this negative sigma and mu, it's gonna be our standard deviation. Okay, it's gonna be our standard deviation. So which means in this case, let's look first. So first inflation point is going to be 255 and 175. So 255 minus 215, it's going to be 40, right? So let's write down. And we check. Bingo. That's correct. Moving to question number 2. All right, so we have three normal curves and we need to compare these three curves. What does that mean? What we are going to have here? So as we can see, the mean is not the same, right? On first one, let's say this one is going to be about 48. Well, if I take half of it, this one, 48 minus, 60 minus 48, it's going to be 12 divided by 2 is 6. So 48 and 6 going to be 54, this one. The other one spike is 60. Third one is going to be, how much? It's going to be between 60 66. So standard deviation is the same because the slope and the curve, it's identical, but the mean is different. So this is going to be our answer. So all three distribution have the same mean. That's already wrong. Has the three distribution have different value for the mean. Okay, this one, do we have any other? Okay, also, so second one and fourth one has different values for the mean. Let me see. Now let's pick between second and fourth answers, because each curve has a different center and the free distribution have different standard deviation. Okay, each curve has different center, but on the other hand, free distribution have the same standard deviation. This is gonna be our answer. Different mean, same standard deviation. Let's check. Bingo. So it can be, let's say, also a case when you have graph like this one, okay, and let's say this one. In this case, let me, so the center is going to be the same, meaning average going to be the same, mean is going to be the same, but standard deviation is going to be different, right? Okay. So moving to question number 3. Let's see what we have here. A dishwasher has a mean lifetime of 11 years. We've estimated standard deviation 1.75 years. Assume the lifetime of dishwasher is normally distributed. Identify the individual variable and type of variable in the content of the problem. So, question number A. So the individual object is, see what options we have. Randomly selected dishwasher, right? Because it doesn't say specifically what dishwashers. So it's randomly. The next one, the variable information collected from each individual. Lifetime. Taken from the problem. It has lifetime. 11 year of, we've estimated mean of 11 years for lifetime. Okay, the variable is, let's see what we have. Quantitative continuous. Why is it like that? Because we are counting, but because it's lifetime, it's nobody knows how long it's gonna run. Okay, what means lifetime? Next. Okay. Question number B. Okay. What is the wording of random variable x in the content of the problem? Let me see. So the mean lifetime, no. The mean, again, lifetimes, no. The mean lifetime, no. The lifetime of randomly selected dishwasher. Moving to question number C. What can the empirical rule be used to approximate probabilities of the problem? Okay, the empirical rule can only be used let me see, it's gonna be which one? Used to approximate probabilities for problem where the random variable has normal distribution. So it's between first and third. So third one is matching. Let me see what is first one. And we can always assume random variable has normal distribution. We cannot. So this one. Okay, so the empirical rule can only be used to approximate probabilities to problems where random variable has normal distribution. Let's check. Okay, we are good. So next question, use the empirical rule to approximate percentage of dishwasher between 7.5 and 14.5. So what is the empirical rule? Remember? So mu, no, I wanted red one. Mu plus minus 1 sigma, it's 68%. Mu plus minus 2 sigmas, it's gonna be 95%. Mu plus minus 3 sigma, it's gonna be 99.7%. Okay? So, let's see what we have. At the beginning of the question, we have dishwasher has mean of 11 years, mean is 11, and deviation 175. Let's write down. And standard deviation 1.75. Okay, we need to figure it out. So when it will last, how many percentage of dishwasher will last between 7.5 and 14.5. So we need 7.5 and 11.5. 11, it's too close. 14.5, sorry. I was wondering. So 11.5, it's almost mu, always our average. Okay, let's figure it out. So what do we have here? So 11 plus 1.75, it's gonna be 12.75. It doesn't match to 14. So let's take twice 11 plus this one, twice 1.75. So 175 times 2, it's gonna be 10, 14, 15, 2, 3.5. So plus 11, it's gonna be 14.5, bingo. All right, so we got 95% plus 2 sigma. Let's check also 7.5. 11 minus 2 times 1.75, which means I need to do 11 minus 3.5. It's gonna be 5, 7, 10 minus 3, 7, and there is 0. Okay, so 7.5. Yeah, we got it, 7.5, which is going to be 95%. Let's check. Bingo. And the last one. So what's the chance if the warranty guarantees dishwasher between at least 7.5? So the low end, or your money back. What's the probability that the company will have to refund money to customer? So we need to find the warranty probability for warranty that goes beyond of 7.5. Okay, so beyond of 7.5. Let's do it. We have for based on empirical rule, this is going to be our 68%, which means 34 here, 34 here. Next, it's going to be 95%. How do we find this area? So 95 minus 68, 15 minus 8 is 7, 8 minus 6 is 27, right? So for these two areas, we have 27. So we need to divide by 2 to get this area. Let me clean so I can write down the number. See, divided 27 divided by 2, it's 1, 3, and 0.5, 13.5. So this is 13.5. And the third one is going to be 99.7%. Here it is, see? I wrote down it's for normal distribution. So how much will be this area? We can figure it out very easy. So 99.7 minus 95, it's going to be 4.7 dividing by 2. This is going to be 2. 7 divided by 2 is 3. 6 and remainder is 5. 2.35%. This is 2.35. And the rest is going to be 0.15 left. Now, since from a previous question we found out that between 7.5 and 14.5 it makes 95%. So beyond is going to be additional 5%, right? So 100 minus 95, 5%. So let's do this 5% divide by 2, because 5% is for both sides, right? We get 2.5%. And that's going to be our answer. Let me write down. So 2.5. Bingo. Okay, we got it. So question number 4. Question number 4 is similar. It just there are some questions that I would like to do it with you. So question up to question number D is gonna be identical. Okay, let me fly over. So what do we have? The mean mathematical SAT score for all people who took the SAT in particular year was 514 with standard deviation 117. Assume the mathematical score is normally distributed. Identify the individual variable type of the variable in the context of this problem. So it's going to be randomly selected, right? Randomly selected person who takes the SAT. Okay, second question. The variable information collected from each individual is mathematics SAT score. Okay. Next question, the variable. What type of variable we have? It's clear that it's going to be quantitative, but because it's about a SAT score, so this time it's going to be the score. It's going to be discrete. It doesn't have lifetime, right? So, we did already this one. Let's go discrete. Okay, this is the case. Next, what is the wording of the random variable x in the context of the problem? So the random variable x, let's see what we have here. The mathematics score, no. Mathematics score, mathematics SAT score of no. SAT score of a randomly selected person, yeah, this one. The mathematics SAT score of a randomly selected person who takes the SAT. Okay. Who takes the SAT, that's one. Okay. Next one, why can the empirical rule to be used to approximate probability of the problem? Let's see what we have. Empirical rule can be used. Can be where random variable has a normal distribution. It is given the probability that random variable has a normal distribution. This one. It's all about normal distribution, empirical rules you can use all around of a normal distribution. All right. Next one. Use the empirical rule to approximate the percentage of people. So between 397, 748. Let's write down 397, 748. Okay, and also we need to know from the beginning how much is 514, 117. So let's see, 748, let's start working. 748, I would say 2 standard deviation probably will fit. So 117 times 2, 14, 2 and 3, and 2. And 514 plus 234, it's gonna be 8, 4, and 7. Bingo. So I was right. Mean plus 2 standard deviation. Now let's subtract 2 standard deviation, which is going to be 514 minus 234. It's going to be 0. 11 minus 3 is 8. 4 minus 2 is 280. Okay, we got too low. So now I'm scratching this and doing 514 minus 1 standard deviation, which is 117. Let's see. 14 minus 7 is 1. 10 minus 1 is 9. 4 minus 1 is 3. There we go. So what do we have? Here we have 1 standard deviation. Here we have 2 standard deviations. Okay, so 2 standard deviations, it's going to be 34. Here it is, 2 standard deviation. So let me write down, this is 3 standard deviation. This is 2 standard deviation. This is 1 standard deviation. 2 standard deviation is going to be this piece, which is going to be 34% plus 13.5. 13.5, and it's going to be 47.5%. This is our 2 sigma. Now here we need 1 sigma. 1 sigma is going to be this 34%. So 47 plus 34, we're getting 81.5%. Okay. %81.5%. All right. And this one, Okay, let's open this one to check. That's correct. So next one, the last one, use empirical rule to find percentage of people who take SAT that will have SAT score at least 514. At least 514. So where do we have 514? That's average. From average all the way to the 100%, it's going to be 50%. But if you would have some, let's say, all the way to here, then you would take 34% at how much we have, 13.5%, and so on. Just add them up, whatever percentage you need. So this one is going to be 50%. I would like to solve one that wouldn't be that easy, but will be by pieces. So I would like to solve it, so make sure you can see. Okay, here it is, 50%. All right, it is correct. So now I'm going to go back and open 6.2, and I want to solve for you this very problem, 6.2, very last one, that I believe it will gonna cause problem with you. Let's go to very last one, this one. Or let me take a teacher's preview, so we can open only teacher preview. It's not a big deal. So use empirical. I'm going to do E, that one that I believe is going to cause some trouble with students. So use empirical rule to approximate the percentage of people who take SAT that will have mathematical SAT score of at least 631. Okay, let me write down 631. Let me clean all this. All right. $631. X is greater, at least 631. And what else do we have here? How much is our mean and standard deviation? 514 and 117. Okay. 514 and sigma 117. So we need to find more than 631. First of all, let's find where is laying 631. Let's check mu plus minus, I would say one. Let's, okay, yeah, one standard deviation looks like. This one is plus one standard deviation, which is 514 plus 117, 11, 2, 3, and 6, 3, 31. So one standard deviation, which we have found out, is 34%, right? One standard deviation, because here it is. Free standard deviation is for 99.7, two standard deviation for the 95, one standard deviation for 68. Well, since we have only half of it, we go take 34. All right, so it's gonna be 631. 631 is gonna be right here, and more. So this is going to be 60. 34%. So in our case, we will have left what? We will have left 13, right? 13 half and plus 13.5 and plus 2.35 we had 2.35. 13.5, and this area 2.35. Okay, 2.35, and we are getting 85, 15, right? And this piece, last piece, is 0.15 between 99 and 99.7 and 100%. That leaves there 0.15. So let's add 0.15 also, because we are interested in greater than 631. 631 we found out laying on 34%, which is right here. So 631. So we need more than that. So it's going to go this way. And that's why I'm adding 13.5, 2.35, and 0.15. And we are getting 10, 9, 10, 5, and 6, 16%. All right. One and 6. Let's check it. I mean, I can open it. There we go. We got it. At this point, then I am done with 6.2. See you at 6.3.